now that we know how to graph from factored form, we're going to start to get into standard form. So just remember, standard form is ax squared plus bx plus c. So you've got all the terms on one side, and you've got them in order from highest exponent to lowest. So what we can do with these, if you notice, problems 1 and 2 are in standard form. And what we're going to start with is we're going to look to see, well, can I turn these into factored form? I mean, factored form was pretty easy, and so we want to stick to something that doesn't require a lot of work. So first thing we're going to do on number 1 is try to find our x-intercepts. So we're going to try to factor this. So f of x, remember, is the same thing as a y. And if I'm going to find my x-intercepts, by definition, x-intercepts are when y is 0. So I'm now solving this equation. And I'm going to try to solve it by factoring. So I know these have an x and an x, and what two numbers multiply to be -3 but add to be -2? This is -3 and +1. The zero product property says, now I'm going to set each of these equal to 0, and I get x equals 3 and x equals -1. So that tells me my two x-intercepts. And this isn't even a new skill, right? You're really not learning anything new today. You've been solving this, and you already know how to graph by factoring method. So it's just putting that all together. So I'm going to plot my two x-intercepts, because now that my equation was factored, I can do that. So x, it crosses the x-axis at +3 and -1. All right, so after we find the x-intercepts, you need your axis of symmetry. Remember, that is the line right in between those two x-intercepts, which is going to be this dashed line I'm drawing right now. Okay, so the axis of symmetry is x equals 1. Now that I know my axis of symmetry, that's going to allow me to calculate my vertex. So in the vertex, I know the x-coordinate has to be 1, because that's my axis of symmetry, and that's what the vertex always lands on. So to find the y value of that, I need to plug in x equals 1 to my function. Now there's two places we can do that. We can plug it into the factored form, just like you guys did with the previous lesson, or we can plug it into the standard form, and we're going to get the same answer. So I'm going to start with the factored form because that's something that's familiar to you. So we want to find the y value because that's the missing piece. So if I plug in 1 for all the x's in the factored form, I get y equals -2 times 2. I get -4. So that tells me that my vertex is 1, -4. Now, if I didn't want to use the factored form, I could have used the standard form, and watch, I'm going to get the exact same answer. So y equals 1 squared minus 2 times 1 minus 3. 1 squared is 1, minus 2 times 1, so that's -2, and then minus 3. Order of operations, 1 minus 2 is -1, minus 3. I once again get -4. So it doesn't matter which form you plug your x back into. If you want to be really diligent in it, you could try it with both of them, just like I did, and make sure your answers match. That's a really good way to double check if your number is correct or not, because you should get the same answer with both equations. All right, so now I need to plot that point, 1, -4. And now I have my parabola. It's facing up, which I should have expected, right? We always look at the a value, and so this was a 1x squared, and 1 was positive. So I should have been able to figure out that, yes, that would be facing up. Okay, number 2, we're going to go through the same idea. We're going to try to use the factoring method, get it to look like something that we've done before. The factoring method would be for our x-intercepts. So I am solving 0 equals, because remember, by x-intercepts, I need the y value to be 0. Now, what's slightly different here, and depending on how good your factoring skills are, some of you will notice there is a GCF. Some of you have also noticed with solving, right, that if you don't see the GCF, you still can get away with finding the right answers. And that's true. What is really nice about identifying a GCF is that it makes your numbers much smaller and easier to factor. Okay, so it's really nice if you can identify it at the beginning. So for this one, GCF is -2. And so that's going to give me positive x squared plus 2x. Oops, here I missed a sign. That was a plus 6 up top. So now that'll be -3. So what I can do now is, because I pulled the GCF, I can quickly factor since I have a 1x squared. See, I have a 3 and a 1, just like the last one, but my signs are going to be different than in number 1. So when solving, this -2 does not have a variable. So it's not going to tell me any information as far as x-intercepts go. I'm going to be just solving x plus 3 equals 0 and x minus 1 equals 0. And those are my 2 x-intercepts. So I can plot those on the graph. Okay. Now, next piece is axis of symmetry. And again, I'm going to look for right in between the two of those. And my axis of symmetry is x equals -1. So very similar to number 1, just had a couple things switched around. Okay, vertex. So I know my vertex is -1 comma something, and I need a y value. So again, I can choose to plug it into the factored form, or I can plug it into the standard form. It doesn't matter. I'm only going to show 1 on this one because I'm kind of limited on space. I'm going to do the standard form since that's the newer idea of the lesson. So I have y equals -2 times -1 squared minus 4 times -1 plus 6. Okay, order of operations. If I square the -1, that gives me +1. Because exponents comes before multiplication. I cannot multiply -2 times -1 and then square that. That goes against the order of operations. We can't do that. -4 times a -1 is going to give me a +4, and then +6. Finish this out, I get -2 plus 4 plus 6, and if you add those from left to right, we get 8. Okay, so my vertex is -1, 8. So if I plot that point, I can now draw my parabola, and this one's facing down. And I should expect that, right? If I look at my A value, that's a -2x squared. I should expect that this parabola would be facing down. Okay, so there's 2 examples, very similar to each other, but different. So when you are solving for, or when you're graphing from standard form, try to see if it factors. If it factors, then you already know how to do it. Okay, nothing new, absolutely no new skills here for today, just putting past skills together. All right, we've got 2 more to do with you guys today. And if you want to pause the video, you can try them on your own and come back to watch it. Make sure you did them correctly, or you can follow along with me, whatever is best for you. Okay, so number 3, we're again going to look to see, can I factor it? And indeed I can. Now, I know a lot of students at first will look at this and say, well, I see a common factor of 3. Maybe I can factor out a 3. And then you've got to realize that there's a 3 and an x that they share. So if I factor out a 3x, that would leave me with x minus 3. So because that GCF did have a variable, we would set it equal to 0, and we would get x equals 0, and x equals 3. So I would plot those. All right, so next is my y-intercept. Now, this y-intercept, the halfway point between 0 and 3 is 1.5. So we are going to be in between a couple grid lines, and that's okay. All right, that's not a really nasty number to work with. Axis of symmetry equals x equals 1.5. Okay, so when I go to put this into my vertex, I know it's 1.5 comma something. Okay, and I have to choose which one of the forms that I want to plug in 1.5 into. Now, me personally, I don't have a calculator super handy, so squaring 1.5 in my head, not 100% sure about, but I can multiply and add to it usually. So I'm going to use the factored form this time. So the y value of the vertex is 3 times 1.5 times 1.5 minus 3. 3 times 1.5 is 4.5. So if I added 3 times, I know that. So I have 4.5 times, see, 1.5 minus 3, negative 1.5. And then if I multiply those two together, I'm going to grab my calculator really quick just to save us a little bit of time. Maybe. Might have to crank it out by hand. We're going to see. All right. All my calculators are dead. So off to the side, let's try this. 4.5 times 1.5. 25. 20 and add the 2 is 22. 1 times 5. 1 times 4. Add. Bring it in 2 decimal places. Y is, that was like a G. Y equals 6.75. 6.75. Okay, so get rid of my scratch work real quick. I'm going to plot that point. So, oops, I forgot a negative sign on it too. And here's what just ran through my mind of how I remembered that it was negative. I know this parabola is going to be facing up. If my vertex was positive 6.75, that would have caused my parabola to be facing down, which I know is wrong because this is a positive parabola. It's a positive 3x squared. Connect your dots, and you have your parabola. Okay, so sometimes you're not going to get super nice and friendly numbers. It's fine, right? Life is messy. Not everything is given to us nice whole numbers. So every once in a while, you are going to have to calculate a axis of symmetry that is not a whole number and have to be able to plug that in. All right, 4. If you haven't tried one on your own yet, 4 would be a really good one to pause the video and try it on your own. So for the X-Intercepts, I am solving 0 equals this function, and I can tell already that there is a GCF of negative 3. So I'm going to go ahead and factor that out first. So plus 4x plus 4. Okay, now that allows me to factor it a little faster, and that's x plus 2 and x plus 2, which says, hey, these are the same thing, so I only have one x-intercept, and that's at -2. So that would be right here. Okay, so for your axis of symmetry, we would have to go in the middle, but we only have one point. So for those of you who've been watching the other videos, you might remember, hey, if there's only one x-intercept, that x-intercept has to also be my vertex. So with all that tied together, the axis of symmetry is going to also go through this point. So axis of symmetry, x equals -2, and my vertex is going to be that same x-intercept point. So now we're going, well, how do I get my other 2 points? I only have one point here. And what you can do is you can go back to tables, okay? If you only have one x-intercept, that x-intercept is also your vertex. So for the minute, you're out of other options. But if you do a quick table, do that off to the side. Let's see, go purple. I know my vertex is always in the middle. So I'm going to put that in the middle of my table. And what I'm going to do is I'm just going to do 1 point bigger and 1 point smaller, one x value bigger and one x value smaller on the x-axis. So this would be, for this example, -1 and -3. And I'm going to plug those in to the function. And again, I can use the factored form or I can use the standard form. For this example, to me, the factored form seems a little bit more manageable, except for I cut the negative off of there. Kind of had that in there. So if I do that, if I plug in -1, I have -3 times, well, -1 plus 2 is 1 times 1. So that gets me -3. So I have the coordinate point -1, -3. And I can plot that on here. And I can do the same thing with the -3x value. -3 from the factored form times -3 plus 2. Well, that's -1 times -1 again. That is going to give me -3 again. So I also have the point -3, -3. Now, this should all kind of make sense because that green line that I have drawn is an axis of symmetry, which means everything's going to reflect over it. So as soon as I knew that first point of -1, -3, I could have just reflected it over that axis of symmetry and also have gotten the point -3, -3. Now, I always suggest still doing the math on the table because it's easy to make a mistake. And that way, if they don't match in your table, then you know, something is off. I've made a mistake somewhere and you can look back at it.